right, I'm going to go through a couple of homework questions just because this is a bit tricky. So let's say we have this chunky looking equation. F of x equal to, on the top we got a whole bunch of things. X plus 5, x minus 3, x plus 3, x plus 4. And on the bottom, I've got x plus 1, x plus 4, x minus 2. Okay, the first thing that you're asked is to find the x-intercepts. Okay, so the x-intercepts are the values of x that make the top of the line 0. And so here we'd have -5, we'd have 3, -3, and -4. So those are your x-intercepts. Underneath this, it asks for your vertical asymptotes. And your vertical asymptotes are the values of x that make the bottom 0, which is -1, -4, and 2. Now you might notice something. We've listed -4 as an intercept and as a vertical asymptote. In fact, if you look at this term and this term are the same. Now, because of that, they essentially cancel each other out. So we cancel, and it's not an x-intercept, and it's not a vertical asymptote. Now, I say they essentially cancel each other out, but they don't entirely. They leave behind a hole, and the hole is at x equals -4. What that means is when x is at exactly -4, if I plug -4 into the top and I plug it into the bottom, then the equation becomes 0 divided by 0, which is undefined. So we can't actually determine the value of this line. We can't actually graph the point -4 because it would give us 0 over 0, and we don't know what the value of 0 divided by 0 is. So this is a hole, and because it's a hole, it's not an intercept and it's not a vertical asymptote. Okay, now let's also find the y-intercept. And the y-intercept is let me just draw this out here. This is the y-axis. At that point, it's going to be 0, comma something. So the x value is 0. So we're going to go take our equation, and we're going to plug a 0 in place of x. And I'll just pause and let you do that. Okay, so hopefully you've done that already. 0 plus 5, 0 minus 3, 0 plus 3, 0 plus 4. On the bottom, you have 0 plus 1, 0 plus 4, 0 minus 2. So that on the top becomes, and then we can cancel these out, so we don't have to worry about those ones. So the top becomes 5, -3, +3, and the bottom there becomes 1, comma, -2. So 5 times 3 is 15. 15 times 3 is 45, -45. On the bottom is going to be -2. And so that is going to be a positive 22.5. So the y-intercept is going to be 0, comma, 22.5. And I'm just checking if I did that right. 15. Yeah, I think that looks pretty good. Okay. Now, the next thing we got to find is the y value. So the y value when x approaches infinity. And let's go back to our equation. We've got x plus 5, x minus 3, x plus 3, x plus 4. On the bottom, we've got x plus 1, x plus 4, x minus 2. Now, again, we can cancel these out for the purpose of end behavior. And the top becomes just this, x plus 5, x minus 3, x plus 3. On the bottom, it's x plus 1, x minus 2. Now, when x is infinity, then let's plug it in the top. You have infinity plus 5 is infinity, times infinity minus 3 is infinity. Infinity plus 3 is infinity. On the bottom, we have infinity plus 1 is infinity. We have infinity. So here, this number is big. This one is small. So big over small is going to tend towards infinity, and that's a positive infinity. Okay, so as you approach infinity, So as x approaches infinity, y approaches infinity. Well, what happened with negative infinity? Okay, so if I plug in negative infinity, right here, negative infinity plus 5 is going to be negative. Negative infinity minus 3 is going to be negative. Negative infinity plus 3 is going to be negative. On the bottom, negative, negative. So this turns into, on the bottom, you have a positive, but on the top you have a negative. You have a really, really, really big negative number. You have a really, in comparison, small positive number. So that's going to approach negative infinity. Okay. Now another way of thinking about this is this. Overall, this thing is, right, we have x, I'm just going to write it one more time, x plus 5, x minus 3, x plus 3. On the bottom, we have x plus 1, x minus 2. Well, if I multiply this out, x becomes x cubed plus some other stuff. On the bottom, x and x becomes x squared plus some other stuff. And when I divide the ones that matter, the only ones that really matter in the long run, x cubed over x squared is x. Now think about the end behavior of x. When I graph x, then as I approach infinity, I'm at positive infinity. As I approach negative infinity, I get to negative infinity. So its end behavior will be the same as this. Now, to get a better sense of how this thing behaves, let's actually do the long division and figure that out. Okay, so we've got x plus 5, x minus 3, x plus 3. On the bottom, we have x plus 1, x plus 4, x minus 2. The next question in the homework asks you to find the horizontal asymptote. Now, the horizontal asymptote doesn't apply here. Horizontal asymptote only applies when the degree on the top is the same as the degree on the bottom. Because that won't be the case here, there will not be a horizontal asymptote. Instead, we have this case, if the degree on the top is 1 bigger than the degree on the bottom, this is the case where you have a slant asymptote. So again, you might want to write this down. A horizontal asymptote is when the top and the bottom have the same power. It could have a coefficient, but if the power is the same, then this will tend towards 7, right? So it'll have a horizontal asymptote. But if the degree on the top is 1 bigger than the bottom, you're going to have a slant asymptote, and it's going to tend towards that slant asymptote. So this one will have a slant asymptote, and to find your slant asymptote, you always have to do synthetic division. All right, so let's clean up this mess, and let's go and do our synthetic division, or our long division. Well, yeah. So on this one, oh, hang on, we've got... So we cancel the x plus 4, cancel the x plus 4. And now let's multiply the top out. So I'm going to do this in a little bit of a different order. I like that x plus 3, x minus 3, because when I multiply those, I just get that, and it's nice and simple. On the bottom, if I multiply these out, I've got x squared. 1 minus 2 is negative x minus 2. Now on the bottom, we've got to multiply that out. So we've got x squared minus 9 times x plus 5. That's going to give us x cubed. This is going to give us 5x squared. This is going to give us minus 9x. And finally, this is going to give us minus 45. On the bottom, we've got x squared minus x minus 2. Now, to find the slant asymptote, we have to do the long division here. So x squared minus x minus 2 goes into x cubed plus 5x squared minus 9x minus 45. So x cubed divided by x squared is x. Now we multiply that out. That's going to give us x cubed minus x squared minus 2x. When we subtract, we flip those signs and add those up. That's going to give us 6x squared minus 7x. Okay, and then we'll bring down that minus 45. Okay, so then we're going to do plus 6, and if we multiply that out now, that's going to give us 6x squared minus 6x minus 12. But we've got to flip those signs, and when we do that, we get our result, which is negative x minus 33. And that's our remainder. We're going to put it on top of here. Okay, so that means that our whole expression, all right, let me rewrite our whole original expression. Our whole expression was x plus 5, x minus 3, x plus 4. On the bottom, you have x plus 1, x minus 2. It means this expression is equal to x plus 6 minus x plus 33 over x squared minus x minus 2. So as x approaches infinity, this will just behave like a line. It'll behave exactly like the line y equals x plus 6, because as x approaches infinity, this part goes to 0. The bottom x squared is going to dominate. It's going to be so much bigger than the top that eventually, as you get closer and closer to 0, this isn't going to have very much influence anymore. Instead, this will keep on behaving just like a normal line. So when we graph it, let's go ahead and combine all of these pieces together and do it. So let's draw our line. And I'm going to pause here. You should probably pause the video and try drawing in these different elements. So draw in your x-intercepts, your vertical asymptotes, your slant asymptote. Okay. So hopefully you've worked at this a bit more. Let's graph the x-intercepts. So the x-intercepts are at -5, -1, 2, 3, 4, 5. This is our x-intercept. The next one is at +3. The next one is at -3. And we have one at -4, but that one is canceled out with the bottom one, so we don't have to graph it at all. Now, underneath, let's look at our vertical asymptotes. We have a vertical asymptote at -1. And we also have a vertical asymptote at 2. Okay. Now, there's a lot of different ways the graph could go here. It could go like this, and then like this, and then like this. We don't really know. That's why we have to test for positive and negative in between each of those points. So it's going to be a bit of work, but let's go through and do it. So this is -1. This one is -3. This is -3. This is -5. And this is 2. And this is at 3. Okay, so those are our critical points. So let's write our equation up again. Our equation is x plus 5, x minus 3, x plus 3 over x plus 1, x minus 2. And you'll notice I'm not including that x plus 4 value because that one gives us a whole, so we don't care about that one. Now let's test something over here. Let's do -6. Now we're going to plug in -6 into this equation and see what happens to the sign. So -6, when I plug it in there, is going to give us a negative, a negative, a negative. On the bottom is going to be negative, negative. Everything is going to be negative. So negative, negative, negative on the top is negative. Negative, negative on the bottom is positive. So it's going to be negative. So in this region right here, we are negative. So this is negative. In between -5 and -3, let's pick something like -4. And if we plug in -4 right here, that's going to turn into a positive. And that's the only one that's going to flip, because -4 minus 3 is still negative. -4 plus 3 is still negative. -4 plus 1 is still negative. -4 minus 2 is still negative. But by changing that one sign, the top becomes positive. And now we have positive over positive. So in this region, it's positive. All right. Now we're going to test something between -3 and -1. Let's try -2. If we get -2 and we plug it in here, that's going to be positive. -2 minus 3, that's still negative. -2 plus 3, -2 plus 3 is positive. So that flips that one. negative 2 plus 1 is still negative, negative 2 minus 2 is still negative. So now on the top, that flips back to negative. Negative over positive is negative. Okay, now in between negative 1 and 2, let's try 0. If we plug in a 0, then, and we actually already did this when we found the y-intercept, but if we plug in a 0, 0 plus 5 is positive, 0 minus 3 is negative, 0 plus 3 is still positive, 0 plus 1, that flips now, that's positive, 0 minus 1 is that. So then the bottom becomes negative, negative over negative becomes positive. Okay, so now we test something in between 2 and 3. So let's test 2.5. If we plug in 2.5, that's positive. 2.5 minus 3 is negative. 2.5 plus 3 is still positive. 2.5 plus 1 is still positive. 2.5 minus 2, that becomes positive. So now the top is negative, the bottom is positive, so that becomes negative. And then after 3, let's choose a number like 10. 10 plus 5 is positive, 10 minus 3 is, and that one is our last one to flip. 10 minus 3 is positive. Now everything on the top is positive, everything on the bottom is positive. So now we can go ahead and graph this. And we are missing a couple bits of it. We'll get to that in a second. Okay, so because this is negative, we're going to be down here in negative land, and then we're going to come up here to positive, and then we go through this, and now we're negative, and now I get to this asymptote, and because I'm in negative land, and because I hit the asymptote, I go straight down. Okay, now on this side of the asymptote, I'm positive, and I never get negative, it's just going to hit the asymptote on both sides like this. On this side, I'm negative, and I come up here and I hit this asymptote. I hit this intercept. Okay, now we're missing something, and the thing we're missing is this. We have our slant asymptote of x plus 6. So let's draw that in. Our slant asymptote of y equals x plus 6 is going to be like this. Okay, and this is going to be 6. It's going to intercept there at 6. And then that means that this is going to, in the long term, its end behavior is going to follow that line. And then over here, it's going to follow this line. And I kind of ran out of space there. But eventually, it's going to follow that line forever and ever and ever and ever. And then one more thing. This thing has a hole. It has a hole at negative 4. So right here at negative 4, we're going to just fill this make this little dot. And that open circle means it has a hole at that point. Okay, so that's a lot of work. That's one question down, 3 more to go. Let's actually check, before we close, let's check what this looks like on Desmos really quick and see how close we got. So on Desmos, try this one more time. We've got x plus 5, and now we've got x minus 3, and then we've got x plus 3, and we've got x plus 4. All right, and then all of this on the bottom, we have x plus 1, x plus 4, and finally x minus 2. And you can see, oh, yep, there it is. So you can see you have your slant asymptote, you have this little dippy thing in the middle, and yeah, let's go back and check our picture and see how we did there. Well, I don't know. We got the basic idea. So anyways, hope you have fun with this, and we can talk in class.